Am I audible? 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 Okay, thanks a lot, Sova. Thanks a lot. So, as discussed earlier, sorry for the delay because of some technical issues. Um, yeah, thanks a lot, everyone. Because of some technical issues, I was not able to basically connect at 11 a.m. sharp. All right. Thanks a lot, Vidij and Suraj Kumar Sova King for joining in. Thanks a lot, everyone. Thanks a lot. So, this is what it is. All right. Give me 1 second. Let me just open up. All right. So, as discussed yesterday, we will be discussing about NumPy. We will be discussing about NumPy. All right. So, this is what it is. We will be discussing about NumPy. So NumPy, as as most of my students are live over here. So as we have discussed earlier, is nothing but a package in Python. All right. It's a package in Python that basically is used for what? That is basically used for your scientific calculations, matrix creation, statistical, basically basic stats calculation like calculation of mean, median, standard deviation, etc. So here we are at a live streaming, first live streaming on our YouTube channel. Thanks a lot for the people who have attended it over here. If you want to basically read further related to every Sunday, we will be organizing a live stream, and it will be related to not only NumPy, pandas, machine learning concepts, deep learning concepts. So if you stay with us, stay connected with us, it will be great. So this is what it is, all right. So now what we'll do is that we'll let's us know more about NumPy. So if you want to know more about NumPy, just go to simply pypi.org, pypi.org, all right, and just type NumPy and click on the first link, and you'll see that this is what NumPy is all about. You will see a basic description of what NumPy is all about, all right. So let me do what, let me share it in the chat, all right. So I've shared it in the chat, all right. So this is what it is, all right. So as we can see, 3 people have joined, no worries. So let us bring in more viewers. Just give me a second, we will start soon. All right, just few more minutes, hardly 1 or 2 minutes, and the session will start. All right. Yes, this will be recorded. This will be recorded. You can uh, recorded after the live class as well. All right, this will be recorded definitely. So without wasting any further time, let us get back to business and let us start with NumPy. So NumPy is what a very important Python package that is used for what, especially that is used in data science, but it is also used for scientific calculations, creation of arrays, all right, creation of matrices, and solving basic statistical function, basically basic stats like a mean, a median, standard deviation, etc. All right. So let us start with the importing of NumPy, which is NumPy as NP. All right. So as I said earlier, if you want to learn more about NumPy, basically what NumPy does, just go to pypy.org and type NumPy in the search bar and click on, basically do what? Let me tell you once again. Go to pypy.org, pypi.org, type NumPy over here. All right, and click on the first link, and here you will get a project description, basically what it does actually. All right, or click on the second, click on the first link. So here are what, here are your maintainers of NumPy. Here are your maintainers of NumPy, and these are the functions that NumPy can perform. All right. So we have imported NumPy. All right, NumPy is what, a package, a library, a module, and as is what, as is our alias. All right, that alias represents what, that alias represents basically our object of NumPy, which we have taken it as NP. We can take any variable for any variable for an object of NumPy. We can take it as ns, we can take it as xyz, we can take it as abc as well. It won't hinder us at any cost, but yeah, np is preferred because np is a short form for what, NumPy. All right, so this is what it is. All right, so running it. So now we've run it. So how do we run it? How do we run this cell? This is what, this is Jupyter Notebooks. All right, how do we run this particular cell? By simply clicking on this run, or by simply pressing shift plus enter. By simply pressing shift plus enter, we will be able to do what, we will be able to run a particular cell in Jupyter Notebook. All right. Or if you want to look at more shortcuts, you can do what, you can just simply open the command palette, and in the command palette you will find what, in the command palette you will find certain shortcuts related to Jupyter Notebooks. All right. So this is what it is. All right. So we have imported NumPy as NP. NPs are what? NPs are object. All right. And object over here is used to what? Object over here is used to basically call out certain functions, or not certain functions, call out all the functions of NumPy. So how we'll do that? We'll take a look at it. So let us create, well, let us first create a list. A is equal to, let's say, 5 comma 2 comma 7 comma 4 comma 1. Now what we'll do is over here, so hash over here represents what, hash over here represents comments in Python. So what we'll do is that convert a list into an array, convert a list into an array using NumPy, convert a list into an array using NumPy. So how we'll do that? It is very simple. Just do what? Create a variable. Let's say v1 is equal to np. Again, as I said, it np, the object, will call out all the functions of NumPy. So np dot array, array is a function of NumPy. All right, np dot array, and I'll write the list over here and press shift plus enter. I'll print this, and as you can see, that very list has been converted it into an array. A list is always represented in square brackets, and if you want to confirm whether A is a list or not, just type over here as the type statement. Just type the type statement or type command and press shift plus enter, and what, list will appear. All right, so this is what is. Am I clear till now? Any doubts anyone has? Any doubts anyone has? All right, I'll take this as a no. Okay, thanks a lot. All right, moving further ahead. Moving further ahead. Next, what we'll do, let us check the type of array or type of v1 variable. All right, numpy.nd array. That means numpy.n dimensional array. So this is what it is. Numpy.n dimensional array. N dimensional means n number of dimensions we can take in an array. So this is what it is. All right. Next, we'll do what? Next, we have seen how to create an array, how to convert a list into an array. Let us directly create an array. Creation of an Array using NumPy. Creation of an array using NumPy. All right. So v2, let us take v2 np dot array. All right. In single square brackets, we'll write, let's say 5 comma 2 comma 7 comma 4 comma 1. All right. Let us print this, and our array has been created. If we want to confirm whether it is an array or not, just type the type statement, type v2 numpy.nd array. All right. So this is what it is, numpy.nd array, and you will get what you will get. You will get the confirmation that whether it is an array or not. All right. So this is what it is. All right. I hope I'm clear till now. All right. Cool. So let us do what? Let us move ahead further. So this is how we create an array using NumPy. NP NumPy is object we declared above. np.array. Array is what? The function of NumPy. Alright, so this is what it is. Next, what we'll be doing is that next we'll be basically discussing how to create a matrix. How to create a matrix using NumPy. How to create a matrix using NumPy. Alright, cool. How to is my screen visible? Alright, how to create a matrix using NumPy. Alright. So now we'll discuss how to create a matrix using NumPy. So what we'll do is that let us take a v1 variable once again, np.array. Alright. Now what we'll do is that in parentheses we'll write double square brackets. Alright, in parentheses, within the parentheses we'll write double square brackets, and inside those double square brackets will be what? We'll write the row entries. Alright, we are creating what? We are creating a 3 cross 3 matrix. We are creating a 3 cross 3 matrix. All right. So what we'll do, let us write the row entries 5 comma 2 comma 7, and after that write comma after the let's say we have written 3 row entries. All right, what we'll do is that we'll write over here as comma and create another square bracket for another row entry. All right, 4 comma 1 comma 8, and after we'll move out of the square bracket, create another comma, and then 11 comma 17 comma 25. So this is what it is. Press shift plus enter and we'll print this matrix, and as you can see our matrix has been created. Our matrix has been created. Alright. Next, what we'll do to check the rows and columns of a matrix. To check the rows and columns of a matrix, what we'll do is that we'll basically of a matrix, it is very simple. Use the shape function. Alright, shape function. So whatever the name of our variable is, matrix is, and over here our name of the matrix is what? The name of our matrix is v1. Alright, the name of our matrix is v1. Alright, so v1 dot shape. So as you can see, 3 comma 3 or 3 cross 3. Now the 3 on the left hand side of the comma represents what? Represents the number of rows. How many rows are there? 3 rows. All right. And the 3 on the right hand side of the comma represents what? Represents your columns. So this is what it is. This is how we basically check for shape of a matrix, basically the rows and columns of a matrix. All right. Any doubts still here? Anyone has any doubts still here? All right. Is the screen visible? All right. Great. Cool. So let's move ahead further. Let us move ahead further. Is the screen visible? V1 dot shape visible? I've written till v1 dot shape. Okay, thanks a lot, Tuhin. Sova, is it visible? Sova, is it visible? All right, I'll take that as a yes. Okay, thanks a lot, Sova. All right, so this is how we check the shape of a matrix. All right, let us do what? To carry out certain matrix calculations, we'll do what? We'll basically To carry out certain matricular calculations, we'll do what we'll basically create another matrix np.array. This time we'll create a very simple linear matrix, 1 comma 2 comma 3 comma basically linear in terms of numbers, 4 comma 5 comma 6 comma 6 comma 7 comma 8, like this. So we have created a matrix. Let us print this matrix and let us carry out a matrix calculation. Let us get into matrix algebra, which is your matrix multiplication. Matrix multiplication is very easy. If you have any doubt related to matrix multiplication, you can Google it. It is very simple. All right. And if you want me to make you understand matrix multiplication, definitely I'll make you understand right after this. Right after we have performed matrix multiplication on Python. All right. So let us store matrix multiplication in MUL. All right, MUL variable, and what we'll do is that we'll write np dot matmul v1 comma v2. All right, so matmul function is what? Dot matmul is a function that basically carries the operation of matrix multiplication. All right, of two matrices. All right, algebraic matrix multiplication, not linear matrix multiplication. Just give me a second. Hello. हाँ जी, बाद में बात करता हूँ अभी. All right. So this is how it. I'm sorry for the interruption. Let me just keep my phone on silent. Thanks a lot. All right. So MUL, I've taken a variable equal to is my assignment operator, and np dot matmul. Np is my object of NumPy. Matmul is what? Matmul is the function that will carry out the matrix multiplication. Now let us print the result. Now as we can see, we have our final product, final result, that is a matrix multiplication of V1 and V2. Now, how has it done that? It is very simple. 5 to 7. Take 5 to 7 under consideration, the row of this V1 under consideration, and the column of V2 under consideration, that is 1, 4, 6. All right. Once again, I'll repeat the row of V1 under consideration, that is 5 to 7, and the column of V2 under consideration, that is 1, 4, 6. All right. So this is what it is. All right. So well, let me repeat it once again. 527 row of V1 under consideration and 146 column under consideration. All right. So 5 into 1. All right. 5 into 1 plus 2 into 4 plus 7 into 6. So 5 into 1 is what? 5. 2 into 4 is what? 8. 7 into 6 is what? 42. So 5 into 1, 5 plus 8 plus 42. 5 plus 8 is 13, and 13 plus 42 is 55. We have our first answer, 55. Similarly, 69, how 69 occurred? So take what? Take 5 to 7 once again and take the second column of V2, 257. All right. So 5 into 2 plus 2 into 5 plus 7 into 7. 5 into 2 is 10. 2 into 5 is 10. 10 plus 10, 20. 20 plus 49 is 69. Right. One last, 335. All right. So 335. So how will basically how 335 occurred? So 11, 17, 25. All right. That is the third row of V1 and the third column of V2. Third row of V1 and the third column of V2. So what will be our output? 7 into 3, 21. 8 into 6, which is 48. And 25 into 8 is your uh, 25 into 8 is your 200. All right. No, 25. Yeah, 25 into 8 is your 200. All right. So I'm sorry. 11, 17, 25 and 368. I'm really sorry. 11, 17, 25. The third row of V1 and the third column of V2. All right. So 11 into 3, 33. 17 into 6 is what? 17 into 6 is 102. 25 into 8 is your 200. All right. Once again, I'm repeating it. 11, 17, 25. The third row of V1 and the third column of V2. So 11 into 3, 33, 17 into 6, 102, and 25 into 8, 200. 17 into 3 is your what? 51. And your 17 into 6 is what? 102. So 102 plus 51 is 153. All right. And 25 into 8 is your 300. So that is how it is giving you your 335. All right, so this is what it is. Any doubts anyone has till now? Any doubts anyone has till now? Anyone, any doubts? Please feel free to ask. All right, great, great. Thank you, Udbhav. So that's how we got our matrix multiplication. All right. Moving towards the alternative for matrix multiplication. Alternative for matrix multiplication is your dot dot function. All right, dot dot function. If you apply dot dot function, it will give you the same output. So this is also what the so the alternative for matrix multi the matmul is your what dot dot. So this is what it is. All right. Any doubts? Please feel free to ask. If anyone has any doubts, please feel free to ask. So this is what it is. All right. So this is what it is. If you have any doubts in the above matrix, please feel free to 11 into 330, 317 into 600 into 102 plus 33 is your 135, 25 plus 8, 25 into 8, 200, 200 plus 135, 335. So this is what it is. All right. So shall we move ahead further? All right. Cool. Let's move ahead further. Let us move ahead further. So next what we'll be discussing is that next we'll there are basic arithmetic operations that can be performed in matrix as well. Basic arithmetic operations like v1 plus v2. All right, it is linear in nature. All right, linear in nature. 5 plus 1, it is given it as what 6. 2 plus 2, it has given it as what 4. So it is linear in nature. There are several others like v1 minus v2. All right, v1, we have a linear matrix multiplication as well. v1 asterisk v2, v1 divided by v2. All right, so this is what v1 mod v2. Mod takes us what mod calculates only the remainder. All right, let us take a 5 for example. All right, let us take 5 for example, and if 5 is divided by 1, the remainder will be what 0. 5 mod 1 remainder will be 0. That is what it is showing over here. So this is what it is. All right. Let us take the exponentiation operator. Exponentiation operator. All right. So v1 double asterisk v2. All right, this does what this means v1 to the power v2. All right, v1 to the power v2. Let us print v1, let us print v2. All right, so it is mentioned over here as 5. Now 5 raised to the power 1 is 5. All right, 4, why is that has it mentioned 4? 2 raised to the power 2 is equivalent to 4. 7 7 raised to the power 3 is equivalent to 343. Let us calculate it over here to confirm 7 exponentiation 3. That means 7 raised to the power 3 is what 343. So this is what it is. All right. So this is what it is. All right. Any doubts, please feel free to ask. Let me grab my charger before my laptop battery gets drained out. All right. Just give me 1 second. Let me grab my charger and let me plug it in. All right, so this is what it is. All right, just 1 second, I'll be back. Just a second, sorry. Yeah, thanks a lot for your patience. Thanks a lot. So the battery was about to almost drain. All right. So why did we not have extra class? We will basically we can cover it over here. No worries. All right. So this is what it is. All right. Cool. So let us do what? Let us basic. So we saw how what is exponentiation operator and all. All right. So don't worry. Every Sunday we'll cover NumPy, pandas, all machine learning algorithms. All right. All deep learning algorithms. We'll basically learn computer vision. We'll learn natural language processing. We learn how to make a chatbot, how to create object detection apps. But for that, we need to have the basics in the right place, the fundas in the right place, basic fundas in the right place. If we don't have that, then it is of no use. All right. Every second day, you will, you know, uh, you will complain that as to, you know, why I'm not able to create an object detection program, why I'm not able to create a chatbot like that. So basics are very necessary. We'll cover everything, don't worry. You will become a data scientist, don't worry, all right? So this is what it is. Moving ahead further. So we saw what? We saw basic arithmetic operations, and we also saw what? We also saw matmul and dot dot. All right. Let us move towards what? Let us move towards basic statistical calculations. All right. Statistical calculations in NumPy. All right. So what we'll do is that we'll basically what basic calculations I'm referring to: mean, comma, median, comma, your standard deviation dot std. All right. Dot min, comma, dot max. All right. So these are the basic calculations that we'll be looking up. So print, we'll use the print statement. Mean of matrix v1. Let me do what? Let me just copy this and paste it. All right, we have five statistical functions. All right, all right. So mean followed by median. All right, followed by standard deviation, min, max. That means the max element and the min element. All right, comma, np dot mean v1. All right, comma, np dot median v1, comma, np dot std, that is your standard deviation v1. All right, comma, np dot min v1, the minimum element. All right, np dot max v1. All right, so this is what it is. It has given us mean of matrix v1 is what? 8.88. Median is what? 7. Standard deviation 7.32. Minimum value is what? Minimum value, as we can see, let us print v1 over here. All right, minimum value we can see is what? Where minimum value is 1. All right, minimum value is 1, maximum value is 25. All right, similarly, it has done what? It has calculated median. Now median is what? How is median calculated? Basically all the elements of matrix in a sorted manner. All the elements of a matrix in a sorted manner. All right, like say 1, we have how many elements? We have 9 elements. We have 9 elements in a matrix. How we'll know that there are 9 elements? Just type v1 dot shape 3 cross 3, 3 into 3, that is equal to 9. That means 9 elements are there. So it is quite valid for, you know, elements that are when there are large number of elements. All right, so it is quite valid for this. So we have 9 elements. So median for odd number of elements is what? The formula for median for odd number of elements is what? N plus 1 by 2. n plus 1 by 2. I'm repeating it once again. The median for odd number of elements are what? N plus 1 by 2, where n represents what? N represents your number of elements inside the matrix, where n represents what? The number of elements inside the matrix. All right. So this is what it is. All right. So in sorted manner. So n plus 1, that means 9 plus 1 divided by 2 is what? 9 plus 1, 10 divided by 2 is equal to 5. 9 plus 1 divided by 2 is equal to 5. That means the fifth element in a sorted position will be our median. So 1 is on first position, 2 is on second position, 4 is on which position? Third position. Fifth is on which position? Fourth position. And 7 is at which position? Fifth position. So that is what it is giving, 7. In a sorted manner, fifth position, 7th. All right. The formula for standard deviation is pretty simple. Summation of x minus x bar divided by n and whole under root. All right. Let me Google it because drawing it will be. All right. Let me Google this. All right. Standard deviation formula is what? Summation of x minus x bar, the whole square divided by n whole under root. Now over here, mu is what? Mu is the mean of the entire matrix. All right. And x is what? Discrete elements of the matrix. All right. So minus it and summate it. All right. The whole square, create the whole square of it, summate it, divide by total number of rows, a total number of elements inside the matrix, and calculate. You will get the final standard deviation. All right. So this is what it is. Very simple. Standard deviation, calculation of standard deviation. All right. Anyone wants me to explain standard deviation? Anyone wants me to explain in standard deviation? Anyone? Please help in project. Yeah, I've helped out a few of your students in project as well. I've helped out a few of your students in project as well. All right. Uh, shall I explain standard deviation or shall I move ahead? How can we get your help? We are connected. We are connected on LinkedIn, I guess. We are connected on LinkedIn. We are connected on YouTube. We are connected on YouTube. I can help you all out. No worries regarding that. All right. Which project do you all want me to basically AK and Neelkant and Vidhi? Which project do you all want me to help you out? Which project? Name that project. Next, in the next stream, I will discuss the project. Please write it in chat which project you want me to stream. All right, please write it in chat. Let us continue further. Let us continue further. All right. So this is how we basically calculate the standard deviation, min, max, and mean, median for a. All right. Next, what we'll do is that let's calculate for the matrix V2. Let's calculate for matrix V2. All right. Let's calculate for matrix V2 and press shift plus enter. So it has calculated what? It has calculated the what it has calculated all the statistical analysis, mean, median, standard deviation, min and max for your V2 matrix. All right. So this is what it is. All right. So this is what it is. So any doubts anyone has? Yeah, I'll be basically starting with the standard deviation process as well. Explanation of standard deviation process as well. All right. Don't go anywhere. Stay over here itself. All right. Okay. So let me open the Jamboard, Google Jamboard. All right. All right. So let us do what? Let us basically start the standard deviation process. Right. Basically, the explanation of standard deviation. So standard deviation is what? Standard deviation is your, as according to the formula, what is the formula of standard deviation? Summation of x minus x bar, alright, where x bar represents the mean of the sample and x represents the individual values of the sample. N represents the total number of elements inside your matrix and whole under root and of course whole square. Now let us take x for example. Alright, let us take what? Let us quickly take three elements only. Three, 1, 2, 3. So what will be the mean of 1, 2, 3? The mean of 1, 2, 3 will be 2. Alright. 1 plus 2, 3, 2, 1 plus 2, 3. 3 plus 3, 6. 6 divided by total number of elements. That is 3. 6 by 3, 2. Alright. Now what we'll do is that we'll calculate x minus x bar. We'll calculate what? We'll calculate x minus x bar. Alright. So 1, as I said, x is what? Discrete values of x. So 1 minus 2, 2 minus 2 will be 0, 3 minus 2 will be 1. So 1 minus 2 is equivalent to minus 1. Alright. Next what it says is that x minus x bar ka whole square. X minus x bar whole square. Alright. So x minus x bar whole square is 1, 0, 1 again. So it will be what? 2. So we've got our numerator value and denominator is what? 3, 2 by 3 and whole under root. This is what our standard deviation is. Alright, this is what our standard deviation is. So this is what it is, alright. So this is how we calculate standard deviation. Any doubts anyone has? Okay, zoom out. Okay, okay, no worries. Thanks for telling me. Okay, just a second. Let me zoom it out. Uh, alright. Is it okay? Is it okay? Data pre-processing and mining. Okay. Yeah, sure. Definitely, we'll talk about data pre-processing and mining. Definitely. All right. We'll talk about data pre-processing and mining as well. Customer service request analysis project. Okay. 2. Customer services request analysis project 2. Definitely, we'll be discussing it next week, this Sunday. All right. So this is what it is. Thank you, AK. All right. So let us do what? Let us do what? Let us go back to NumPy and all right. So any doubts in the statistical, the standard deviation part, the mean part? I hope it's all clear. It's very basic of NumPy. So the idea behind this was to basically teach the basics only. All right, and nothing more than that. All right, great, great. Excuse me. So let us take, so NumPy is all about functions, different functions. So it gives us a base. These are basically baby steps towards becoming a data scientist. So this is what it is, all right. So this is what it is. So let's move ahead further. Let's talk about let's talk about the reshaping of matrix. All right, let's talk about the reshaping of matrix. Reshaping of matrix. So let us create a matrix. Let's say A. All right. So this is our last topic of the week. All right. This is our last topic of the week. Basically, this stream. Next, in the next stream, we'll take up a project. All right. Or as per the demand, whatever the demand is. If the demand is more of the project, then definitely we'll go for the project. If the demand is for any tutorial, any package tutorial, then definitely we'll go towards package tutorial. All right. So this is what it is. If there is a project, I don't know worries. I'll upload a video also. No worries regarding that. Right, so let us reshape the matrix. So for reshaping the matrix, we need to do what? We need to create np.array first. All right, we need to create np.array and then let's create a matrix 5, 2, 7, 4, 1, 8, 11, 15, 17, 25. All right. So this is our matrix has been created. Let us check the shape of the matrix. So what is the shape of the matrix? Drag the screen to the left. Okay. Thanks for informing. Yeah. Thanks for informing. Yep. Right. So what is the shape of the matrix? 2 comma 5. Let us print the matrix over here as well. The shape of the matrix is what? It's 2 comma 5. All right. Next, what we'll do is that next basically we'll basically reshape the matrix. Now remember, if the shape is 2 comma 5, please listen to this very carefully. If the shape is 2 comma 5, then what we need to do is that we can only reshape the matrix in what? In divisibles of 2 comma 5, that is divisibles of 10. 2 into 5 is what? 10. Divisibles of 10 will be what? 1 into 10, 10 into 1, all right, and 5 into 2. Though only these three divisibles it can be reshaped to. Otherwise, it cannot reshape because it will take it as a loss of information, and it will say that the accesses are not matching, and it will throw an error. So it can be only reshaped in divisibles of 10, 10 comma 1, 1 comma 10, and 5 comma 2. So let us reshape it into 5 cross 2. 5 cross 2. So how we'll reshape it? So let us have a look at it. Let us create a dot reshape 5 comma 2. So as you can see, the matrix has been reshaped. It has taken two concurrent variables, all right, 5 comma 2, 7 comma 4, and 1 comma 8, and it has reshaped it. 17 comma 25, and it has reshaped it. So this is what it is, all right. So this is what it is. Next, let's create a reshape of let's say 10 comma 1. Again, it has reshaped it into a set of columns, created one column and 10 rows. Let us create a reshape of 1 comma 10. So in a set of 10 different column and one row. So this is what it is, all right. So this is what it is. Next, let's move ahead further. Let's talk about what? Let's talk about another form of reshape, which is known as the transpose of a matrix. Which is known as what? Which is known as a transpose of a matrix. All right. So how do we transpose? It is very simple. A dot t. That's it. Dot t function. Dot capital T function, and it will do what? It will transpose. Now over here, what is the difference between the reshaping of this reshape 5 comma 2 or reshape basically using transpose? All right. What is the difference? Transpose basically converts the rows into columns and the columns into rows. Transform does what? Converts the rows into columns and the columns into rows. Alright, so this is what it is. And while reshape does what? It takes two concurrent elements and converts them into columns. As you can see, let me print A over here. So as you can see, 5 and 8. 5 and 8 are what? One column. It has converted them into a row. 2 and 11 are what? One column. Row. 7, 15. Row. So this is what it is, and so on till 1 comma 25, 4 comma 17, and 1 comma 25. So this is what the concept of reshape in a matrix is. All right, let us know how to create a ones matrix. All right, so how we create ones matrix? It is very simple. Np dot ones, write the shape of the matrix 5 comma 5, and sorry, also mention the square brackets as well. So it will do what? It will create a 5 cross 5 5 dimension one shaped matrix. Let us store it in, let's say, 1. All right, and run this. Print 1, and let's print the shape of 1. So it is showing it as what? 5 comma 5. So this is what it is. All right, so this is what it is. Any doubts still here? Anyone, any doubts still here? Okay, thanks a lot. Sova, you are from Simply Learn. Okay, thanks a lot, Sova, for being a constant companion throughout. Thanks a lot. All right. Asha, Pranav. Okay, okay. Hi, Pranav. How are you? Thanks, Pranav, for being a constant companion throughout. All right. Thanks a lot. All right. Let us create what? Let us create a zeros matrix. All right. So this is what it is. Let us keep it as zeros variable, and let's do what? Let's take up np dot zeros. All right. 5 comma 5. So it will do what? It will create a 5 comma 5 zeros matrix. We check the shape of it. If we check the shape of it, it will be what? The shape will be zeros dot shape. So this is what it is. All right. Next we'll do what? Next we'll basically check for let's create a diagonal matrix, or let's create a diagonal matrix first, then we'll create the identity matrix. So let us create a list. A is equal to, let's say we already have a list, I believe. Okay, we don't have. All right, no long. A is equal to 5 comma 2 comma 7 comma 4 comma 1. All right, what we want to do is that we want to induce diagonals. We want to induce this 5 2 7 4 1 in the diagonals of a matrix. All right, so what we'll do is that np.diag a, let's print d. As you can see, 5 2 7 4 1 have been induced in the diagonals of the matrix, and rest are all 0. And what will be the shape of this matrix? It will be 5 comma 5. As how many numbers I have passed? I have passed 5 numbers. Let us pass one more number, 25. It will automatically become a 6 comma 6. 25 will be added to the diagonal. All right, so this is how we create a diagonal matrix. All right, let us create what? Let us create identity matrix. Now identity matrix is what? Where the uh, your column, basically your diagonals are 1 1, and the basically rest of the elements are 0. So 1 comma 1 comma 1. So let us create d1 np dot diag, or let us create as I3 identity matrix of 3 order, np dot diag a. All right, let us print I3. I'm sorry, I3. So as you can see, of order 3 identity matrix has been created. We can also create it for order 5 by doing what? np.diag b. Now np.diag b, let us declare b over here. Let us create a list and declare 5 ones in it. Alright, so it will do what? It will basically print 5 elements of np.diag. So this is what it is. Alright, alright, so this is what it is. So this is how we create a diagonal matrix. Alright. So I think that's enough for today. We discussed only the basics. In the next week, what we'll do is that we'll take up a project. We'll take up a project, all right. And after taking up a project, what we'll do is that uh, we'll basically discuss the remaining part of NumPy as well. We'll start with the remaining part of NumPy, and then we'll do what? We'll basically start with a project as well. All right. So any doubts anyone has till now, please feel free to ask. Any doubts anyone has till now? Any doubts anyone has till now? Thanks a lot, Pranav. Thanks a lot, everyone. Thanks a lot, Udbhav. Thanks a lot, everyone. Thank you all. Thanks for joining in. Next week on Sunday, same time, 11 a.m., we'll basically stream another session. All right. The session will be much bigger than this. All right. Thanks a lot, everyone. Thanks a lot. Bye bye.